we now have a SQL database to talk to, so let's connect to it in our API project. This video is part of a series dedicated to developing C# applications on Linux. Along the way, we're getting a better knowledge of how Linux works and how to make our apps truly cross-platform. If you haven't already, subscribe to this channel to stay informed of new episodes as they come out. There's a full playlist for this series, so you can look at just subscribing to that or subscribe to the whole channel. If you're looking for even more .NET, SQL, and AI training, go to iamtimcorey.com. All right, let's move over to our project. And if we open up our SQL Server, we can see that, yes, we have our TicketDB running here. And we're going to open up our API service and start working on this project. Now, we're just going to connect to the SQL Server and maybe just have one endpoint, just to have something. Like right now we have the weather endpoint. We're going to change that, get rid of it. But we will have just one endpoint just to show that, yes, we can connect to SQL Server, because it's important to establish at least talking to the database before you start planning on how to work with the database. Because if you can't talk to the database, it doesn't matter what your plans are. From there, you're dead in the water. So let's start with adding, let's right click and say add a NuGet package. I'm going to add the Dapper package. Oops, 2Ps. And we're going to say Dapper and the latest version 2.1.72 as I'm recording this video. That's fine. What that does, if you don't know, is it puts this package reference right here in our project, our CS proj file. Now we're going to do it one more time because I want to add a reference to SQL client. So manage NuGet packages. We're going to search for Microsoft.data.SQL client. And there we go. And the latest version 7.0.1. Of course, if you have a later version, cool, use a later version, but that takes care of what we need to do to talk to SQL. So Dapper doesn't just talk to SQL, it talks to lots of different database types, but this allows us a very, very small micro ORM. If you haven't used it before, I use it a lot because of the fact that it allows me to let SQL do what it does best and let C# do what it does best. If we start moving too much work over into our C# side that is database stuff, well, then our performance is going to be hurt long term. And if we put too much business logic in a SQL, that's going to be a performance issue too, as well as a maintenance issue. So we want to make sure we hit that balance of making sure we don't have too much in the database, but not too little either. We can't swing the pendulum either way too far. So Dapper allows us to hit that middle ground. Essentially, all it does is a wrapper around ADO.NET, and it says, hey, let's get the data and let's map it back to types. That's it. That's pretty much all. Yes, there's a lot more it does, but that's really the focus of what it does. So we're going to take full advantage of that in our code. Now, what we're going to need to do is we're going to need to add a connection string. Now, I could put it in app settings.json, but the problem is that this gets then put into source control. We don't have source control on yet. We need to turn that on soon, but that would be put in source control, and that means that my database username and password, which we're going to be using, is going to be shared to the whole team, and I don't want that. So instead, we're going to use a user secrets. So what we need to do is we need to manage user secrets. That's a right click on the project. And this is a CS proj file, but notice I'm sorry, not CS proj. It's a JSON file, but it's not in the hierarchy of our CS proj. So it's actually in my .microsoft / user secrets / a GUID / secret.json. What this does is it makes sure that this secret does not go into source control. Now, you're going to be saying, well, but it's in clear text, and so anybody can read it. Anybody that has access to my profile can read it, which means they have access to my computer, which means they have access to all my stuff. So yes, but also no. So I don't worry about this, especially since I'm not putting production secrets in here anyway. I am putting development secrets that are from my machine. So we need to say connection strings, and then in here, we need to say in new line, we're going to say default. Actually, let's say instead of default, we're going to say, I don't know, what we call a database. We called it TicketDB. Let's call it the same. All right. So a TicketDB, we need to build this connection string. This connection string is going to start with server equals, I'm going to say localhost, so 127.0.0.1, semicolon. Database equals TicketDB. And then we're going to say user space ID equals SA. And password equals, and this is where people freak out, but yes, this is what you need to do. Let's give the whole view here. Password equals test 1, 2, 3, 4, 5. That was the password we used when we created the database. And then trust server certificate equals true. So this is a connection string. There's 4 parts to it. There is what database server, which machine is it running on? That's the 127.0.0.1. Now, if we were running on a different port, then we put that port in there too. We don't have to because we're using the standard port. Then which database do you want to connect to? Now, this is the default database. That does not mean you're limited to this database. If you have permissions, you can go to other databases as well. So this is just the default. Next up, we have the user ID. That's whichever user wants to connect to the database. Now, because this is a local database for testing purposes, I'm using the SA permissions. SA is the server administrator. This is like the big bad account that can do everything. This was not what you would do in production. This is absolutely not what you do in production. Production, you need to limit this to just what it has access to. Otherwise, it can do horrible things if someone were to compromise your system. So for development, SA is just fine. Although you might want to mirror that eventually at some point in your testing so that you know that your limited permissions can still do all the things you want it to do. Password, it's in clear text. It's right there. This is something people freak out about. They really want to encrypt it because they think that encryption is going to solve this. Encryption does not solve this problem because this computer has to have access to the raw version of this password to send a SQL. So therefore, even if it's encrypted, this computer has to decrypt it, which means that if a person has access to this computer, then they have access to the decrypted version of this password, even if it's encrypted. So encryption is not going to help you here. And again, this should be a development server. So don't worry about that. And that unless you're using the same password or your production server, then don't do this. But you shouldn't be doing that. So trust server certificate equals true. The server certificate is in a VM or in a Docker container. So it's going to be different and untrusted. Just say, hey, go ahead and trust that server certificate. So that's the 4 parts. Again, coming back to this is where I love Dapper because we have a pretty high level account right here that's accessing our database. We don't have to. We can say that we create a new login for our database and say that login only has access to execute stored procedures. That's it. And then it can't create tables, drop tables, can't list the tables. It can't say select star from a different table. It can only get access to whatever the stored procedures have access to do and only the way they provide it. It can't get access. Remember I said that this database is basically a suggestion. It can go to other databases. Yeah, it can't do that if your permissions are locked down to only one database and only the stored procedures. So make sure that you're thinking through this. Do not just give admin rights to your system when it's in production. That's a bad thing because what happens is if you have a SQL injection attack or some other attack that bypasses your UI and gets access to basically this connection directly, well, if it's being opened by an SA, a system administrator or server administrator, then it's going to have access to drop tables, drop databases, list tables that you hadn't expected, go into the master database and make changes, create new users, so many other things that you don't want to have access to do. So the downside is if you're using like a full ORM, they often, like Entity Framework and Hibernate, they often have to have a larger set of permissions in order to do things like create tables and drop tables and add columns, etc., more than just even viewing the data. So you got to be careful with that. Make sure you limit as much as possible. Okay, I'm going to hit save on this. That's secrets.json, connection strings. So we should be good here. We don't have to put anything in here if you don't want. Or we could do this where you say connection strings and then say ticket DB and say empty string. So this is what I typically do, because then what happens is that, and I did put that in the same line. That's my bad. Let's go back here and put that in the right line. I get used to C#, and that's not what we're doing here. We're doing JSON. There we go. Keep the formatting correct for the thing you're working with. So even though we have this one here, it's empty, what it's doing is saying, hey, this is what we need, so that then when you pull this down from a repo, you can say, oh, I need to put this in my secrets.json. Just copy and paste it and then fill in the actual value, because secrets.json will override this. Therefore, we're good. And if you don't have anything, if you forget to create a secrets.json, it's going to throw an exception, which is actually what you want. Okay. So in here in our program.cs, we're going to get rid of most of this. Let's get rid of the summaries. Let's get rid of our map get here for weather forecast. Don't need it. Let's get rid of our record. Don't need it. Cool. Okay. So now what we need to do is we need to create a way to connect to SQL. So we're going to create an endpoint here. We'll say app.map.get, and we're going to say this is, it depends here if you want to do the API / or if you want to just say the root. I'm going to say API /. So yeah, API / and then we're going to say, let's go with tickets or ticket. And what this will be is we're going to ask for all the tickets. So we're not going to have a limiting factor here. We're just going to say, give me all the tickets. So it's essentially going to be a select star or the get all. So we have in our database here, if we go to tickets, programmability, store procedures, we have our get all. So we're going to call that store procedure here and return all the tickets. Now to do that, we have a little bit of work to do because we don't yet have a model to put in, and we don't have the connection to our database. So let's create the connection. I'm going to create a new file here, and let's say we're going to create a class, and we'll call this class SQL Data Access. And we could put it right in the root, or we could put it in a folder. I'm going to put it right in the root. It's fine, I think, for right now. Okay, file scope namespace. I like that. Let's create our, let's either using Dapper and using Microsoft.data.SQL client. Because we're going to need those. Okay, so here, this is what I do. I create a couple of simple, let's create a constructor first. CTR, and we're going to say I configuration config, and then typically what I do, and I don't have the control dot here to actually do it, so we'll do it manually, is we're going to say I configure private, if I spell right, private I configuration config, and I use the underscore here. and then I say config equals config. That way I take my dependency injection value of iConfiguration and put it into this iConfiguration that has the underscore. The underscore tells me that I'm not going to modify this. I'm going to treat it like it's a read-only. Now, I'm not making it read-only, but I'm going to treat it that way. So now I can create two methods here, public. I've done this a number of times, so I've kind of built and tweaked this over time. If you've seen me work with Dapper before, you'll recognize this. List of T and say load data of type TU. And I'm going to say string stored procedure, U parameters, and string connection string name. Okay. And I will, let's show you the whole thing. There we go. I'll probably, let's just do this. And we'll do it one more time. So it's a little more compact here. Okay, so what this load data is going to do is it's going to call a store procedure. It's going to pass in any parameters we have, and there's a connection string name for which database we're talking to. And it's going to return back a list of T. Whatever model you pass in, it's going to give you a list of that model in return. So let's start with a connection string. Let's just do, connection string. We'll do the full name. Abbreviations get hard because you have like connection and connection string. So which is the CONN? Is it, or CNN? Is it connection or connection string? So full names are often less ambiguous. So what we're going to say here is underscore config dot get connection string, and we're going to pass in the connection string name. Now it's going to throw a warning here because this is a string, not a nullable string. And yet, if the connection string doesn't exist, it's going to return a null. So we need to do something here. And this is where I am going to throw new, let's just throw it for now a new exception that says the connection string does not exist. We can get specific on which thing that is, which exception type that is, but there you go. So now we're guaranteed that connection string will have a string in it, a full connection string. Because if it doesn't, like if connection string doesn't find, the get connection string doesn't find something, then what's going to happen instead is we're going to throw an exception, which will stop this from executing. So this should only happen in development when we've messed something up, or initially in production if we forget to move over our parameters into something like Key Vault or the environment variables in app settings or something like that. Okay, so now we have our connection string. Now we can do is say using IDB connection, and let's call this connection, equals new SQL connection. And we're going to pass in the connection string. Okay, so now we're using the newer way of doing using statements. And what this is normally put this in parentheses and have curly braces and have another indent. We don't need to do that because this is saying, hey, I want you to keep this connection open until the end of the scope, which is this end curly brace right here. And that's going to close the connection for sure. It's important to use this, though, because of the fact that we want to make sure this connection gets closed no matter what. We have a connection to an external database. We want to make sure it's always shut down. This is one of the areas where there's so many problems with your application bloating up over time or your database, coming to a halt. This is probably the reason why is you didn't use the using statement. And so what happened is you're losing connections, where connections are staying open longer than your application is running. Okay, so now we have a connection to the database. We can say list of type T rows equals connection dot query of type T, stored procedure, parameters, and then the command type is going to be store procedure. Okay, it's yelling at me because this is why. So right now I've got the I've got to put to list. There we go. Okay, let's read this whole thing. I'll shrink it down so we can actually read it. So there we go. There we go. There we go. All right. So this is opening a connection to SQL. Now it's using the type T. And if you're not familiar with generics or you're not sure what's going on here, basically we're going to pass in a model type. So this is going to be, we haven't created the model yet, but it's going to be a model that is going to be something like ticket model. And that will have the ticket information that we need. And we're going to pass that model in, or the type in, and say, I want this back as a list of that model. That's the output I want. That's another. So this query is going to say, okay, here's the model to map to. And what I want you to do is I want you to create a map that will create one model per row. And then we're going to return all the rows, right? So the store procedure name is, what are you calling? That's going to be our get all, right? So we're going to do get all there, and then we're going to pass in parameters. This would be things like, do you want to limit to a certain ID? Or if we're creating an insert statement, we're not doing an insert here. This is just a get call. But if we were doing insert, we'd pass in things like, a ticket title and ticket description, etc. And then finally, we are specifying the command type here, and that is a store procedure command, because we can also do ad hoc queries, which I'm not a huge fan of ad hoc queries in C#. But this would be where we could say, yeah, I could do select star from, the ticket table. So I use store procedure because I like to have all of my SQL in SQL. So all I have in C# is the name of the store procedure. Some people say, well, you're putting SQL into your C#. You have to put something. If you use something like Entity Framework or Hibernate, what you're doing is putting the whole ad hoc query inside of C#. I prefer just to have the store procedure name. That way we can put all of our actual code for our T-SQL for calling that table inside of SQL. Okay, so that's the call. And the final statement is return rows. And that is all we need to do to list the data, to get data, to load data. All right, now I'm going to copy this actually, because I want to create another version of it. So this is going to be save data. It's going to be a little bit different. And we're just going to pass in type T. And it's going to return a void. All right, and it's going to type T parameters. You could, in order to be consistent, you could say U here for parameters if you wanted to, and just say a U here. Your naming of your lettering for your generics can be whatever you want, right? So pretty much the same thing. Let's get rid of the return here, but we're going to open it. We're still going to get the connection string. We're still going to open a connection to the database, but instead of query, we're going to do an execute. So execute, and it's not of type T. So we're going to call the stored procedure. And actually, we need to make these async. I didn't make these async. I should have. We'll do it in just a minute. But the execute is going to execute the stored procedure, and then we're done. Now let's make this async, because I should have done it in the first place. await and async. And actually, I don't have to await this. I can just execute it if I wanted to, but I'm going to await it. That way, if I have any problem, I can have it right here. But just know you don't have to await every call. If you don't need to do anything with it, then you can just pass it back. But I'm going to await it here. That does mark our save data as async task save data. Now, I could call a save data async, but I'm not going to do that. I don't think that we need to do that. It's a debate because here's the thing. If I mark it as async, well, that is very clear that that's an asynchronous method call. But the reason we mark our method calls as async is because we're also mixing them with our synchronous calls. So when you had synchronous calls and you wanted to make it asynchronous, you didn't just change your synchronous call to asynchronous. That would break compatibility with all the things that have been calling those things. So we create a separate method that's the async version. But if you're creating it from scratch, then you don't necessarily have to do that, but it does kind of fit into conventions. What we have now kind of is this weird case where the workaround became the standard. So I'll call it save data async, but that does mean we need to mark this as async as well, which means that we can come down here and say query async. But that causes a problem. So we also need to say async task of type list of t, like so. But this causes a problem here because of the fact that we're expecting back rows, which is a to list. The problem is that this query async, we have to await it in order to do that. But if we're awaiting it, then we can't do a to list on it because then we're doing a to list on the task, not on the results. So what we have to do instead is we have to wrap this inside of parentheses, like so, and then we're good. That's one way of doing it. The other way of doing it would be to just have a return value that we then do to list on. So, but this way we wrap in parentheses with the await inside, and that's going to await that call. Once it returns, then we're going to do a to list on it and put that into rows and then return the rows. Okay, so now we have our asynchronous call to our database. We have our asynchronous save. The only difference between load and save is save doesn't execute, which calls a store procedure, passes the parameters. It's a store procedure type, but it doesn't return any rows. Now there is a return value. So there is a return value of type int, and this would be the number of rows affected. You can also have different return values. I'm not going to worry about that. I'm keeping this really simple. We're going to hit save. So now we have our SQL data access. We need to put this into our dependency injection. So we have our services right here. Let's keep adding with our services. So we'll say builder.services.add singleton of type SQL data access. So now I have to do a control dot here to add the using statement for this, or using directive for this. So I could create an interface for this. Normally I do, and there is a debate on this. If it's really needed or not. I like to, for my dependency injection, have interfaces. That way I can mock them very easily. I can replace them very easily without having to go in and say, no, actually, I'm going to override the SQL data access. So that is one reason to do it. We're not doing unit testing or other testing in this application, so I'm not going to worry about it. But just note that I would normally probably create an interface for this just to make it easier for testing purposes. Okay, it's also easier to replace, but we're not replacing our data access. Don't start thinking that you're going to replace your data access with like a different database type or something like that. You're not going to do that. Once you get into production, you're stuck with where you are. So it's very, very, very rare. And if you do, you probably haven't gotten very far into production. because once you get into production in a significant way, you need to stick with what you've got. Okay, so we're almost ready, but we still have one more thing to do, and that is if we look here at our let's go to tables actually, and go to columns. We have to create a model that matches this. So let's create a new model, and we're going to put it right in the root again because we, whoops, not that. New file. There we go. And we're going to say this is the ticket model. I could put this into its own directory, and if the API got too large, I probably would. But you don't need to add complexity if you don't need the complexity. So I'm going to open up my database view here. That way I can create this model very easily. And what we're going to do is say prop, and I'm going to say int ID. And then I'm going to say prop, and we're going to say string, and this is the ticket title. And the question is this nullable? No, it's not nullable. But the thing that's the question here is, in your model, are you going to allow it to be null? Because that's different. And if you try to connect your database to your model too closely, you're going to cause some problems. So in our database, we should never have a null value for ticket title. But when you're creating a ticket, you might have a null value until you've finished creating it. So let's do this for sake of our sanity. We're going to say it's nullable, not because we're going to allow null to go through the database, but because of the fact that we're going to allow null to be a possibility, which means we're going to check for null in places where we depend on it not being null. Okay, so same thing here for our ticket description. And as someone pointed out in the comments under a previous video, we don't have to say ticket title and ticket description because we have it in the ticket table. We could just say title and description. This is kind of a holdover for me from trying to link a bunch of tables together and having things like, you have multiple things that have title in them. And so you have to look at what the table is for it. It just is a little messy sometimes. So I often default to this, but you don't have to do that. You can just say title and description. It's just fine because it really is clear when it's attached to a table. Okay, so then we have a date time, and this is going to be our date created. And then we're going to have a date time that's nullable, that is date completed. And actually, you know what? We should mark this one as nullable as well, the date created. And you might say, well, wait, Tim, no. We shouldn't do that because that's never null. Well, actually, it is. When we create the ticket in the API, we're not going to know a date created because we're going to let the database do that. Remember, the database has that default value that it puts in for date created. Therefore, we're not going to populate it. We could populate it. The problem is then if we populate it, then we'll have a problem where maybe put in a different time, slightly different time, or we use non-UTC time. That'd be a problem. So we're going to leave that as null when we populate it. Okay, and then priority is an int. We could at some point change this to be a enum of some type, but we'll leave it as an int for now. That's just fine. Okay, now we have a model that matches the data that's going to be in our table. Just to be clear, in this case, our model matches one-to-one with the columns in our table. That is not always the case. So, and even note that some of our values, our types, are different than the table. This is because this model is for C#. The table is for SQL. So there's two different things, and don't try and get confused as to, they should be the same. You're not going to necessarily have, if you have multiple tables, which you obviously would in production, you're not going to necessarily have just one model per table. Like you'll have different models for tables. You might have models that have more information than is in one table. So don't think it's a one-to-one relationship. It just works out this way for our very, very simple example. Okay, so now we have our ticket model in place. Now we can come over here. Let's actually collapse this down. Now we can come into our tickets. The first thing to do is we need to ask for that SQL data access and call it SQL. So this is our connection to our database. This is where, this code right here, that may be a little confusing to you because it's generics and it's, a whole bunch of stuff. But when it comes to actually calling it, once you figure that out, I love this. So let's actually call this. We're going to say var tickets equals SQL dot load data async. Actually, need to await this. So we'll await this, and we're going to say, notice it marked this now as async. We're going to await this and say we want to get the ticket model. And then for the type, we'll say dynamic. And we're going to pass in dbo.sp tickets underscore get all, right? That's the name of our store procedure. SP tickets get all. Yep, cool. So, and then we're going to pass in the a new, I'll explain this in just a minute, a new empty object, and then the ticket DB. Okay, this right here represents, and let's actually put this on the new line. This right here represents opening up a connection to SQL, calling this store procedure with these parameters, which is nothing. This database, actually this connection, so it's referencing this connection string. Calling the SQL at this connection, this store procedure, these parameters, getting back the data, mapping it to a list of ticket model. All of that in one line. So now we can just say return tickets. So now if we call the API / ticket, let's go tickets. Tickets. If we call this endpoint, we should get back all the tickets in the database. So now what we need to do is we need to actually run this. So let's run our application, make sure it works. This is always a moment of truth, where you run it and everything breaks. Wait for it. Yes, we need to fix this, but for now, we need to add our token in. So our token is this right here. Copy that, paste it in here, log in. Okay, our API service is up and running. We can click on this to open up our API again. We need to fix these certificate issues. So now we should be able to say /API / tickets. And if we do, we get this. Let's pre-print it. There is our tickets. So we have now validated we have a connection to the database that we can open up. We can make a call. All of our data is set up so that now we're set up to actually start working with our endpoints and start adding in endpoints, knowing that, let's close this down now, knowing that really all it takes to talk to our database now is the name of our store procedure and one line of C#, and we're good to go. So this will make our endpoints so much easier to work with because we just say, go, go, go. So That's going to be in the next video. We're not going to spend more time on this video, but I want to make sure we got the connection up and running. They worked through any issues we had with connection strings. Make sure you're using the right password. Make sure you're using the SA if you're using the server administrator login. But all of this, making sure it's all working correctly. If you use a different port, you need to put a different port right here. All that stuff. We wanted to validate that this all would work. It is working, so we're good to go. And so now we can move on to the next video. If you want access to the source code, I will include a link down in the description of this video to get access to the source code. It will email you. So check that out if you want. If not, either way, thanks for watching. And as always, I am Tim Corey.